5.3 is on maximizing with application problems. One of the most common problems or applications of calculus, you run into these a lot, is determining maximum or minimum values. So when we do that, we have some steps to follow. If you follow these steps, then that can kind of help us stay organized and hopefully get us to the right answer. So number one, you want to choose the variables and make sure if you need to, some problems require it, some don't, you want to draw and label a figure. Second thing is you want to write up a primary equation. This is really important. Your primary equation should be with, you want to isolate whatever you're trying to maximize or minimize. So when you read the problem, focus on what is it asking you to maximize, what is it asking you to minimize, and that's what you're going to try to isolate or get by itself. 3, rewrite the equation with only one variable. Sometimes you'll have 2 variables, a lot of time, you'll have 3 variables, excuse me. In that case, usually they'll give you some kind of secondary information where you can come up with a secondary equation that you can substitute back in for one or more of the variables. But the idea is to narrow it down so you only have one variable on each side. Number 4, check the domain. Number 5, you want to take the derivative, find the critical numbers, make a number line. Right? We're trying to find max and mins. So this is just like finding the relative max and mins. You're using that first derivative number line, just like we have before. Okay, so we got this example right here. Very first one, it says, a box with no lid is to be made from 48 square centimeters of material. If the box must have a square base, find the dimensions that will produce the maximum volume. So I'm going to start with my figure right there. Let's decide what our variables are. So I'm trying to find, what I'm trying to maximize is the volume. But over here, let's start. We're talking about the volume of this box, so let's label it. It does say it has a square base. So I'm going to call the 2 sides of the base both x. Since it's a square base, they have to be equal. And then the height doesn't have to be the same, so I'm going to call it y. So I've got x, and y. So the x in the bottom are the length of the square base, how long the side of the square base is, and then y is the height of the box. Okay, number 2, come up with an equation. Now, your primary equation has to involve what you're maximizing or minimizing. So in this case, it says if the box must have a square base, find the dimensions that would produce this is the important part, a maximum volume. So when I come up with my primary equation, it has to involve the volume because that's what I'm trying to maximize. Well, we know we can tie the x, and the y together with volume, just using the volume formula, right? If I have a rectangular prism, I just go length times width times height. So the volume is going to be equal to length times width times height. So I have volume equals x squared times y. Now notice I have 3 variables there. Right, step number 3 is we want to write it so you only have one variable on each side. So I have the volume, I'm good there. But over on the right side, I don't want both the x squared and the y. So I need to come up with some kind of secondary equation that will allow me to substitute something in for the x squared and y. So look at whatever other information it gives you. It says a box with no lid is made from 48 square centimeters of material. Hey, this part right here, that is the surface area of the box. Like that's how much material you have to make the box. So I'm going to use that to come up with a secondary equation. So just think about it. The bottom of the box down here, the area of that bottom of that box right there would be x squared. So I've got to go x squared plus the sides of the box. So if I look at one side of the box right up here, like that side right there, that would be x times y. And there's going to be 4 of those around the box. So it's x squared plus 4xy. And when I add that, and there's no top, so when I add the bottom of the box plus the 4 sides, when I add them together, it has to equal the total surface area or the total amount of material you have there, which is 48. Okay, so that gives me a secondary equation. What I want to do is either solve for x or y there and substitute it in the other equation for x or y. When I'm looking at this equation, it looks to me like it'd be easier to solve for y. Right, solving for x is difficult because of the x squared and the 4x. I can't really get x by itself, at least not easily. So I'm going to solve for y. I'm going to minus the x squared over. So I have 4xy equals 48 minus x squared, divide by the 4x. So y is equal to 48 minus x squared over 4x. Okay, I'm going to go over now to my equation, my formula over here I'm going to use. And in place of the y, I'm going to replace it with that 48 minus x squared all over 4x. So now I've got an equation that just involves two variables. I have v on the left side, the volume on the left side, and I have x on the right side. Okay, the next one is to find the domain. So I'm looking to find the domain. I'm looking, because my equation is in terms of x, I'm looking to see what x can equal. I'm going to come back over here and I'm going to think about this equation right here. I'm going to erase those 4x's. We divided by 4x, right? I'm going to come over here and just think about what can x equal right here. So think about x represents the side of the box. So we know that x cannot be negative. So if we think about that for a second, to get a positive, what are my constraints? To get a positive, the top has to be positive and the bottom has to be positive. So I'm going to do this. I know that 48, I'm going to find out when 48 minus x squared equals 0. So let's solve that. I'm going to add the x squared over. 48 equals x squared. Take the square root. So x equals plus or minus the square root of 48. So that's when it equals 0. Well, just think about this for just a second. If x squared is greater than 48, greater than the square root of 48, okay, for example, it could be the square root of 49. That would be, when I squared, I'd get 49. 48 minus 49 would be a negative number. And that means y would equal a negative, which is not possible. So I know x has to be smaller than the square root of 48. Also, just think about the problem. X has to be greater than 0 because it's a side length. It can't equal 0. So step number 4 is find the domain. I'm going to put that up here at the top. I'm going to say x has to be greater than 0. No negatives, right? And it has to be less than the square root of 48. Anything bigger than the square root of 48, and this would come out to be a negative, which means y would be negative, and that's not possible. So x has to be between 0 and the square root of 48. Okay, number 5. We're going to now take the derivative and do our number line with that. Before I take the derivative, I'm going to take that equation and just make it a little easier to work with. So I'm going to, if I have x squared times this, I can cancel out that x with one of those. So I get the volume equals x times 48 minus x squared. And then I get times through by, over 4, sorry. Then I get times through by the x. So I would get 48x minus x cubed over 4. And then I can actually still take that and split it apart. I can write that as being the volume equals 48x over 4, which would be 12x, minus x cubed over 4, which is really the same thing as 1/4 x cubed. The reason why I did that, I'm going to erase this up over here. The reason why I did that is because up here, if I did it as I did up here, I'd have to do the product rule and the quotient rule, and I'd take that derivative. That's really difficult. If I do it like it is right here, I still have to do the quotient rule. Now I don't have to do any of that. I can just do the power rule. Okay, so let's take that equation. Let's take that equation and find the derivative. So v prime would equal 12, drop the 3 down, so minus 3/4 x squared. So there's my derivative. And now I have to find out when that equals 0. So I'm going to add the 3/4 x squared over to the other side. So 3/4 x squared equals 12. I can times by 4. So 3x squared equals 48. Divide by 3. So x squared equals, what's that, 16. Take the square root. So x equals plus or minus 4. Okay, let's do our first derivative number line, or in this case, I'm going to call it my v prime number line. Now, here I have two critical numbers, plus or minus 4, so negative 4 and positive 4. But if I think of my domain, It's up there, right? The domain I said x has to be between 0 and the square root of 48. That means -4 doesn't fit in my domain. So I'm just going to go on here and just go, I'm going from 0 and I'm ending at square root of 48. And my only possible critical number is 4. Okay, now we're going to test it just like we normally do. So pick a number on either side. If I pick, for example, 1 and plug it in, 1 squared is 1, 3/4 times 1 is 3/4, 12 minus 3/4 is a positive. Pick a number to the right. Maybe let's try to pick something that works out like reasonably. Square root of 48, by the way, is 6 point something, right? It's got to be a number smaller than, it's got to be 6 or smaller. Maybe let's do 5. So if I square 5, 5 squared is 25. 25 times 3 is 75. 75 divided by 4, I don't know what that is, but it's bigger than 12. So 12 minus that is going to come out to be a negative. Okay, so the question is, we want to find out what dimensions would produce a maximum value. Well, from our derivative here, our function for our volume function down here, it has a max at 4, right? It goes from positive slope to negative slope. So 4 is a max. But the question isn't asking, so that would be x equals 4. But make sure you answer the question. So the question is asking, what are the dimensions? Well, it'd have to be 4 by 4, but I need the y value too. So we got to go back, and I should not have erased my secondary equation. But it was y is equal to 48 minus x squared over 4x. So if I plug 4 into there, 4 squared is 16, 48 minus 16 is 32, over, plug 4 into here, 4 times 4 is 16. So when x equals 4, y is equal to 2. So my dimensions would be, you need to write a sentence to answer this, right? It says right there, answer with a complete sentence. You would say the dimensions that maximize the volume are 4 by 4 by 2. So the dimensions that maximizes the volume is 4 by 4 by 2. And if you want to be specific, you could say the base is 4 by 4. And I should label those, I'm sorry. We're talking about centimeters. So 4 centimeters by 4 centimeters, and the height is 2 centimeters, and that would maximize the volume. So if you follow those steps, these are long and they're complicated, but if you follow those steps, then it can kind of help you step yourself through there. So remember, first, come up with your variables, draw a figure if necessary. Second, write a primary equation, and the thing to remember with that is to make sure that your primary equation includes what you're trying to maximize or minimize. The next step is, if you have more than 2 variables, then you got to come up with a secondary equation so you can do some substitution, because when you do these problems, you can only have 2 variables before you take the derivative. Do your number line, verify that it really is a max or a min or whatever you're trying to find, and make sure you write your sentence to your complete answer. Okay, let's do another one. This is a different, we're trying to maximize, minimize problem. Still one of those, but it's a little bit different it's a lot different than the last one. So this one says the product of 2 numbers is 288. Find the 2 numbers so that the sum of twice the first plus the second is as small as possible. Okay, so let's come up with our variables here. I'm going to say, we have 2 numbers, so I'm just going to say x is the first number and y is the second number. So x is the first number, y is the second number. There's no figure to draw here, right? So we don't have to worry about that. Okay, the second part is come up with the equation we're going to use that gives us what we're trying to maximize or minimize. So read the problem again. The product of the 2 numbers is 288. Find the first 2 numbers so that the sum of twice the first plus the second is as small as possible. So this is really important. This doesn't say max or min, but it does say as small as possible. That means we're trying to minimize. That's what we're trying to do. And you have to focus on what are you trying to maximize or minimize. So in this case, we're trying to minimize the sum. Trying to minimize the sum of twice the number plus the second number. So I'm going to put this down. I'm going to use an S for sum. So I'm trying to minimize the sum. And it's a sum of twice the first number, that would be 2x, plus the second number. Now, if you look at there, what are my three variables? Well, I have, first of all, the sum. That's what I'm trying to maximize or minimize. That's one of my variables. And as x and y change, the sum changes. And I have x and I have y. So I've got three variables. I need to do some substitution, so I only have two. So either I need to come up with a secondary equation that involves x and y, so that I can substitute something in for x or for y. Okay, let's come up with our secondary equation here then. At the very beginning, it says the product of two positive numbers is 288. That means x times y equals 288. So we need to pick what we want to substitute for. That's up to you. We can do either one. I'm going to just go in for y. Oops. So we're divide by x, divide by x. So y is equal to 288 over x. So I'm going to come over here and do my substitution, come up with my equation. S equals 2x plus, and in place of y, I'm going to put what I got there, 288. Because I'm going to take the derivative, I'm going to write it this way. 288 x to the negative 1. It'll make it easier to take the derivative. Let's talk about our domain. So if x is our first number, what could x be? Well, it says it's a positive number, so I think it's got to be, x has got to be greater than 0. Oops, did that the wrong way, didn't I? So we know x has to be greater than 0 because it's a positive number. Okay, I think we're ready. Now we're going to take our derivative. The hard work's really done. Now we're just going to take our derivative and find the minimum. So let's take our derivative. So s prime is equal to the derivative of 2x is 2. Drop the negative 1 down, so minus 288 x to the negative 2, which I can really write this way, right? S prime equals 2 minus 288 over x squared. Okay, we want to find out when the derivative equals 0, so plug 0 in for the derivative. We're finding our critical numbers here, right? By the way, 0 would be a critical number, but we just said x has to be greater than 0, so I don't have to worry about that. So 0 equals, I've got 2 minus 288 over x squared. I'm going to add that to the other side. 288 over x squared equals 2 times by the x squared. Divide by 2, 144. Take the square root. So x equals plus or minus 12. Those are my two critical numbers. Put them on the number line. Remember, my number line starts at 0. So think this right here is 0 is where I'm starting. So my critical numbers are plus or minus 12. The only one I'm going to use is a positive 12. Okay, let's test on either side. We've got to make sure that it's a minimum, right? That's what we're looking for. So pick something to plug in. We could plug in, for example, 10. 10 squared is 100. 288 divided by 100 is like 2.88. You subtract those, you get a negative. Okay, plug something in bigger than 10, or 12, excuse me. So let's pick something that's easy to plug in. Let's do 20. 20 squared is 400. 288 divided by 400. I don't know what that is, but if I go 2 minus that, it's going to be a positive. Okay, so we verified 12 is a minimum. Okay, now we need to actually answer the question. So always write a sentence. So we're going to say the two numbers, let's see, the first number, 12, and the second number, whoop, I never found the second number. If I plug 12 into here, back into my secondary equation, oops, sorry, up here. Let's plug 12 into there. So we're going to go 288 divided by 12. I'm pretty sure that's 24. Let me just double check. It is 24. So we would say to maximize, to find the minimum sum, to make the sum as small as possible, the first number would have to be 12, and the second number would have to be 24. So that would be the sentence I would write. That makes sense? So to minimize the sum, the first number would have to be 12, the second number would have to be 24. So again, just following those steps. Come up with your variables, draw a figure if necessary. Second step is write your primary equation. Make sure you focus on what you're trying to maximize and minimize with that primary equation. If necessary, rewrite it so that you only have two variables. You have what you're trying to maximize. Sometimes that will require you to come up with a secondary equation and do some substitution. Check the domain, find the derivative, and then just do your number line and test it. We will do, so 4.4, excuse me, is on maximizing and minimizing. 5.5 is on the same. So there's kind of some different types of questions we'll go through on 5.5, but it's really the same concepts. All right, thank you.